All right, let's go over Chapter 8 test. Okay, a parcel of land is the shape of a triangle. I'm just going to draw a triangle. The lengths of the sides are 250 feet and 375 feet. So this one probably should have been longer than that one, but that's okay. With an angle between the sides of 114 degrees. So this should have been over 90, and I drew it under 90, but that's okay. It's still a triangle. So I sketched the parcel. Not a very good sketch of it. Determine the other angles in the sides. Well, I have side, angle, side, which is great for a law of cosines. The side opposite the angle is equal to the sides adjacent to the angle squared. Minus 2 times those two sides multiplied. Times the cosine of the angle between. So I'm just going to put that into my calculator. It was kind of a messy screen. Oh well. 250 squared plus 375 squared minus 2 times 250 times 375 cosine of 114. Make sure my mode is in degrees. It is. And so I can press enter and I get c squared is that. So I take the square root. Easy way is go to the 0.5 power and I get that side, this other side, to be 528.57 feet. So I've got the side. Now I got to get an angle. So I can use the law of sines for that. The sine of 114 divided by the side opposite equals the sine of any other angle. I'll go for this one. I'll call it theta, sine of theta over the side opposite. That's opposite. So if I multiply by 250, figure this out, and then take the sine inverse. So I want the sine inverse of 250 sine 114, that divided by my last answer, second answer, close parenthesis, press enter, and I get this angle to be 25 degrees 60 minutes round, or 25.60 degrees. Not, that wasn't minutes. 2560. So then, since I have these two, I can subtract them from 180 and find the last one. So I'm going to take that one, that angle, plus 114, and then do 180 minus that answer, and the other angle is 40.40 degrees. So determine the other angles and the sides. So I got part B done. Find the area of the parcel. Well, that's 1/2 side, side times the angle in between. Side, side, sine of the angle some angle between the sides. So that's the 114. So it's going to be 0.5 times 250 times 375 times the sine of 114. And the area turns out to be 42822.44 square feet. I'll write this down. 1/2 times 250 times 375 times the sine of the angle between them. Okay, number 2. We got to come up with this silly looking leaf, clover, whatever. So when I look at this, I'm thinking, okay, it looks like it's going out as far as 6, touches the radius of 6 and a radius of 4. So there must be something to do with 5, and it must be going out and then coming in and doing maybe a small loop or the big loop, I don't know, but when it comes in, it doesn't go, for this quadrant, it doesn't go as far out. So I'm going to write R equals 5, and a trig function. See, this doesn't seem to be starting on the x-axis, or maybe it is over here, starting on the negative x-axis. So maybe it's negative. So it starts, when it starts at 0 degrees, it's going a negative radius, -5 cosine then. So if I go 5 cosine, and I've got 3, so I'm thinking it's either 3 theta or maybe 6 theta, I'm not sure. So I'm going to go to my calculator and do a little estimating here. I'm going to put in -5 cosine. We'll try 3 theta, and I'll graph that. That does 3. What if I do, I better do zoom 4. There's more proportional. I wonder if I do 6 theta. Oh, get on the right place there, 6. Okay, so now that has more leaves. I don't know if it's 3 or 6 yet, but the problem is we need to do some that are further out than others. So I'm going to put, there's a theta in here, and I don't know whether it's 3 or 6, but I'm going to do, let's see, I can add 1 maybe, so that when it's positive, it goes out to 6 instead of 5, or goes out to 4 instead of 5, because that would be negative +1, and then more or less on the other. When it's negative, it'll be, when the cosine's negative, this will be positive, it'll go out 1 more. So I'm going to put a +1. It doesn't look quite right. I'm going to go back to 3. And my window, I'm not going far enough. I need to go from 0 to 360. Do from 0 to 360. Let's graph that. There we go. That looks like it. Okay, just FYI, if this minus wasn't there, it does the same pattern, but positive on this side instead of on this side. So I had to change the negative on the cosine. The sine would rotate it so that it's going either up on this one or this one. I'll show you that. So now it's down, and if I put a negative on it, then it would be up. Okay? So that's a little bit of what's going on that one. All right. Page 2. Some people got confused on this one a little bit. Let's see, what was the equation? There it is. Y equals sine 2 theta minus 2. So it makes something that looks sort of like a peanut, but I needed to draw it only from negative 90 to 90. So I want to get that part of the peanut. Now, since the equation's in there, if I set my table set on to ask, table set onto ask, I can go to table and I can put in the negative 30. See, these, I typed all these in, and then negative 60, and there's 100 in there. I didn't need that one. And it tells me these numbers, negative 2.866, negative 2.866, so there's some symmetry going on there, and minus 1.134. Some people had trouble seeing where those were. Negative 30, that's down this way, 330 or negative 30, but I'm supposed to go a negative radius, so instead of going into the positive 330, I have to go negative 2.88, somewhere about not quite to 3. And at negative 60, I had to go a negative radius, which brought it up somewhere up here also. And at 60, I had a negative radius again of negative 1.34, somewhere down there. Now, if you remember right, I can make a list of a whole bunch more angles so I know how to graph it, but I can also just hit the graph, and it looks like it starts up at 2 at 90 degrees. Negative 90 times 2 is negative 180, and the sine of negative 180 is 0. So I get negative 2. For negative 90, I have to go to plus 2. The negative of, or I have to go a negative radius, which takes me up to 2. And it goes out, and it crosses at 2 there. For 0, if I put 0 in here, 2 times 0 is 0, sine of 0 is 0, and I get minus 2. So at 0 degrees, I have to go minus 2. Back 2 in that direction. So I get that, and then it comes in a little bit more, and then it starts going back out towards 2. That peanut shape. The other part of the peanut would be over there. Okay. Well, r sine theta, we're supposed to write this in rectangular. We know that y equals r sine theta, so this is 2 over y. And r squared, we know that the radius is the square root of x squared plus y squared. That's one of our conversion formulas. So r squared would be just x squared plus y squared. Convert this to polar. So that's my x and y, and the r is the square root of x squared plus y squared, so 5 squared is 25. 2 squared is 4, so 25 plus 4 is 29. Square root of 29 is the radius. And the angle is the inverse tangent of y over x. So inverse tangent of y divided by x. And since x is positive, we don't have to add or subtract anything. And we get negative 21.8 degrees. Again, that's using this for r, and the theta is the tangent inverse of y divided by x. And you add 180 if x was negative, but it wasn't. Okay. This is in polar, radius and angle. So to find y, you do r sine theta. To find x, you do r cosine theta. So we're going to do r negative 4 cosine 110, and x is 1.368, and y is, I just have to change the cosine to sine, and it's negative 3.759 approximately. Okay, now I've got to draw a picture of u plus v. That's u, so I'm going to draw something that looks like u. Let's see, that's about that long. Yeah, it's about the right length. And it looks like they're pointed about the same direction, close to the same direction. U. Started here, went to there. Then I got to do V from where I left off. And V is in this direction, so I got to go in that direction. About the same length as V. So this is U. This is v, and so u plus v is a vector that goes from where I started to where I ended after doing both of them. So there's a picture of u plus v. Now I have to draw a picture of u minus 2v. I'm going to go up here so you can see those and do u. So another u, which is something like that. And it looks like it should be a little bit longer. Yeah, that's about right. And then minus 2 v's. So that's a plus v, so minus v goes that direction. So I got to go that direction twice. So I started here, went to there, then that, and that. So ended there. So my answer is that vector. That's u minus 2v. And now the back page. So u is in rectangular coordinate components, -4, 3, and v is 5 at -40. Find the rectangular components for that. For that, it's just 5 cosine 5 cosine negative 40 3.830. And for the y, I just have to change. By the way, if I want that one back, you can arrow up onto it, or you could just go second, enter, brings up the last entry, just brings it up, and then I can go back and push sign on it, change the cosine to sine, and press enter, and I get negative 3.21, 4 rounded. Here's my x and y coordinate, x and y components for that one. So now when I have x and y components, I can just go three of v, so three of those x's minus 2 of those, and then I can go 3 of that component minus 2 of that component and get the sum. So I'm going to do 3 times 3.830 minus 2 times negative 4. And I get an x component for this new vector of 19.49. And the new y component would be 3 times that, 3 times negative 3.214 minus 2 times 3, and I get negative 15.642. So this is the vector in component form and x, y components of that. I could change it to polar if they asked me to by doing that squared plus that squared square root for the r, and the theta I could do tangent inverse of that divided by that. Don't have to, I'm just supposed to figure this out, and so I got it. Now it says determine a unit vector in the direction of u. U was the vector negative 4, 3, but it's not 1 unit long. That's what a unit vector is. So I have to shorten it. Now, how long is it? Well, it's got a length of negative 4 up 3, so that's negative 4 squared, or 16, plus 3 squared, 9. That's 25 squared. It's 5 units long. So to make it only 1 unit long, I have to take 1/5 of this coordinate and 1/5. I got to divide both of it by the length of that. So I get a new vector that's 1 unit long. That's negative 4/5, 3/5. That makes it a unit vector. If I do that squared plus that squared square root, I'll get 1, making it 1 unit long. And finally, I have a barge floating in a river or lake or something, and I got 2 tugboats probably, I didn't say that, pulling on it. There's a force of 19,000 pounds at 20 degrees. So if I just set up a trig coordinates, I got one at 20 degrees. That's 19,000 pounds of force. And I got another one that's 12,000, so it's a little bit smaller vector at negative 10. So I got to go at negative 10 degrees and go a little bit shorter, 12,000. Okay, so I got to add these two vectors. So I can write this one and then this one and try to figure out the angle between them. Or I can write this one in components and this one in components and then add the components like we did up here. I think students generally find it easier to go to components, so I will do that. So I'm going to take the first one, the 19,000 pounds of force, cosine of 20 degrees, and I get an x component of 17,854, and I want to add it to the x component of this one, so I'm just going to go plus the x component of this is going to be 12,000 cosine of negative 10. And whatever that was added to that, the x component of this plus the x component of that ended up to being 29,672 pounds. And now we'll do the y component of this plus the y component of that. So I'm going to go 19,000 sine of 20 plus 12,000 cosine of negative 10. That's the other one. And I get a y component that's positive 18,316. So I'm getting these two pulling on it, which goes out to there, is going this way 29,000 and up 18. That 18 seems a little high. Let me check my numbers here. 19,000. Oh, I didn't do so sine on that. It seemed high. There we go. Shouldn't be very big. Yeah, there we go. 44146. 4414.65. It should have been a lot in this direction and a little bit in the y direction. This plus this would go there. A lot in the x direction, a little bit in the y. So there's the sum of the two forces. Now, if I wanted to put it back in polar form, I would do that squared. So that would be 29,672 squared plus 4415 squared to the 0.5 for the square root, and I get the length of this vector, of the sum, is 29999 rounded. Almost 30,000 pounds of pull force on it at, what's the angle? So I'm going to do tangent inverse of 4415 divided by 29672, and the x is positive, so I don't need to add anything. That's at 8.46 degrees, which looks about right. It's up a little bit from straight out. Okay.